Okay, for this lesson, we're going to take a look at multiplying radicals, and typically in a little bit more complex a fashion than what we've done in the past. So some things we should already know. When I am multiplying radicals, I can multiply the radicands. So if I put root 2 times root 3 in my calculator and I put root 6 in my calculator, then that is going to be true. If I put 2 root 5 minus times negative 4 root 3s, or put in negative 8 root 15s, that's also true. It's just multiplying the radicands, multiplying the coefficients. If I put in the square root of 2 times the cube root of 4, it's not the cube root of 8. This one is false. If I put in 2 cube root 10 times 3 cube root 7, it is the same as 6 and the cube root of 70. And last but not least, if I have 4 and the cube root of 5 and 7 and the square root of 2, it is not equal to 28 and the 6th root of 30. That is false. So, how do I multiply radicals? Well, step one, when I look at what's wrong here, I know that the index must be the same. If it's a square root, I can multiply it by a square root. If it's a cube root, I can multiply it by a cube root. Then what do? I just multiply the radicands. Or what's inside the radical, and I multiply the coefficients. Or what's outside the radical. That's really it. And the only thing that I need to add to that is then typically I'm going to have to simplify the radical after I've multiplied everything out. We're always simplifying radicals. It's a common statement. So if I do this, multiply and simplify where possible. If I take the square root of 8 times the square root of 8, that's going to be the square root of 64. And the square root of 64 is just 8. Now, I'd probably take a note of this. It's really important, and it's going to come up again later. If ever I have square roots, then the square root of x times the square root of x is always just going to be equal to x. If I multiply a square root by itself, it's just going to be what the radicand is. Every single time. All right, moving on. If I have 4 in the fifth root, 4 in the square root of 5 and 3 in the square root of 6, then 3 times 4 is going to give me 12. 5 times 6 is going to give me 30. And I can't divide 30 by any perfect squares, so I'm done. When I get to example C, 4 times 3 is still 12, and x times y is just xy. I don't have any pairs of the same. They're not 2 x's or 2 y's, which means that this is the end. Last but not least, when I go to example D, negative 2 times 5 is going to give me negative 10. 8 times 12 is going to give me 96. And 96 is factorable by a perfect square. Negative 10. And this is going to simplify to 4 root 6. So negative 40 root 6 should be my final answer. Always, always, always simplify at the end if it is possible. All right, for example 2, we still need to use the distributive property. Like I said, this is very similar to polynomials. So if I have the square root of 5 times 2 root 10 minus the square root of 5, I'm going to multiply it into both terms. I'm going to distribute it out. So I'm going to take the square root of 5 times 2 root 10. This just has a coefficient of 1, so 2 times 1 is just 2. And 5 times 10 is going to be 50. Minus. You can do this in 2 steps if you want. You can say 5 times 5 is going to be the square root of 25. Or you can use that rule that I had previously stated. Root 5 and root 5 is just going to make 5. I'm going to simplify the first one down to 5 root 2. And then 2 times 5 is 10 root 2's minus 5. And there's my final answer. When I get to the next example, I need to expand it into all 3 terms. Doesn't really change my process. So I go coefficient by coefficient. 2 times 3 is 6. And 5 and 45 makes 225. For the next one, 2 and negative 8 is negative 16. And root 5 and root 5 can just be bracket 5. Now in this case, I need to put brackets around it because I need to multiply it out properly again. But the radical cancels out. And finally, 2 times 3 is 6. And root 5 and root 20 is root 100. Now, one of the convenient things here is that both of these radicals actually happen to just be perfect squares. So 225 is going to simplify down to 15, but I'm going to put it in brackets so I expand it out properly. Negative 16 times 5 is going to give me negative 80. And 6, and the square root of 100 is just 10. Multiply it out, and I'm going to get 6 times 15 is 90, minus 80 plus 60, or my final answer is 70. When I multiplied it out, it actually canceled out all of my radicals. Going on to example C. Now be careful here. When I multiply these out, I need to multiply both of these terms by negative 2. So it's going to change the signs in there as well. So what's this going to give me? It's going to give me 2 root 3's minus 2 root 5's minus the square root of 12 and minus the square root of 20. I'm going to simplify down all the ones I can, so the first 2 can't be simplified. But the square root of 12 is the same as 2 root 3, and the square root of 20 is the same as 2 root 5. And then I'm going to combine my like terms. Root 3 with root 3. Root 5 with root 5. The root 3's actually cancel each other out. Positive 2 root 3 and negative 2 root 3 means I'm left with 0 root 3's. But the negative 2 root 5 and the negative 2 root 5 leave me with negative 4 root 5's. Example D, same process. We're just adding in a variable, which doesn't really change anything. So if I take negative 4 root A times root A, the root A times root A will cancel out, and it's just going to be negative 4 A's. Negative 4 and negative 9 is going to give me positive 36, and root A and root B, root A, B. And I'm done.